26 centuries ago, a man in a Greek trading port asked a question that broke history in two. Before him, every storm was a god's anger, and every harvest was divine favour. After him, the universe could be explained by the universe itself. This man was Thales of Miletus, and he invented the way you think. Not his specific answers, but his method of asking. He proposed that reality has an underlying structure that human minds can discover through observation and reason. This was not obvious then, and remains revolutionary now. Every scientific theory, every rational explanation, every attempt to understand nature without invoking magic traces back to him. We possess not a single word Thales himself wrote. Everything we know comes through later thinkers, primarily Aristotle, writing over 200 years after Thales lived. This creates a genuine scholarly problem we must confront honestly. Much attributed to him may be legend, projection, or the natural tendency to credit founders with later achievements. Yet certain core ideas emerge consistently across ancient sources with enough reliability to reconstruct his thought. We will distinguish carefully between what we can reasonably attribute to him and what remains scholarly speculation. What follows is not a simple biography or a catalogue of trivia. We will examine the deep structure of his thinking, the assumptions underneath his claims, and their consequences. We will trace how his ideas rippled through philosophy, mathematics, and eventually into modern science. We will see where he was wrong, where he was surprisingly right, and where his questions still lack answers. Most importantly, we will understand why his approach changed everything about how humans investigate reality. Part 1. The Revolutionary Question. Thales was born around 624 BCE in Miletus, a prosperous port city on the western coast of Anatolia. Miletus was then the most important commercial centre in the Greek world, positioned on major trade routes. Merchants from Egypt, Babylon, Persia and mainland Greece passed through constantly, exchanging not just goods, but ideas. This matters enormously because isolation breeds intellectual stagnation, while exposure breeds questioning. Thales grew up where different cultures with different explanations for reality collided and mixed. When you hear multiple contradictory stories about why the Nile floods, you start to wonder which one is actually true. The dominant explanatory framework of his time was mythology, not as quaint stories, but as genuine explanations of how and why things happened. Lightning existed because Zeus hurled thunderbolts from Olympus in moments of anger. The sea was calm or violent because Poseidon was pleased or displeased. Crops grew because Demeter allowed them to grow, and failed when she withdrew her favour. This framework had internal consistency and answered the question of causation by pointing to divine agency. But it made prediction essentially impossible because the gods were capricious, emotional, and fundamentally unpredictable. Thales asked a different kind of question. What is the fundamental substance from which all things are made? Notice what this question assumes that was not obvious to his contemporaries. It assumes that there is a fundamental substance, that multiplicity reduces to unity at some level. It assumes that this substance is natural rather than supernatural, material rather than divine. It assumes that human observation and reasoning can identify this substance without divine revelation. These three assumptions constitute the foundation of what would eventually become natural philosophy and then science. His answer was water. All things originate from water, exist as transformations of water, and return to water upon dissolution. At first glance, this seems obviously wrong, and perhaps embarrassingly primitive. Yet this reaction misses what was genuinely revolutionary about the claim itself. Thales was not offering another myth, but a hypothesis based on empirical observation and logical inference. Aristotle, our main source, suggested several reasons Thales might have reached this conclusion through observation. First, all living things require moisture to survive and wither when deprived of water. Seeds themselves are moist, and semen, the material of biological generation, is liquid. Heat, which seems to be another fundamental force in nature, appears to derive from and depend on moisture. When things die, they dry out, suggesting that life and moisture are intimately connected. These observations were available to anyone, but Thales drew from them a general principle. He moved from specific observations to a universal claim about the nature of all matter whatsoever. There is a deeper reason, connected to his specific geographical context, that scholars have noted. Miletus sat at the mouth of the Maeander River, which emptied into the Gulf of Latmos. Within living memory of Thales's contemporaries, the island of Lade had visibly grown larger in the Gulf. River sediment was literally creating new land from water before their eyes. The ruins of Miletus now sit 10 kilometers from the coast because the process continued. Thales could watch water appearing to transform into earth over human timescales. He would have known about the Nile Delta, the Tigris and Euphrates deltas, and other places where rivers created land. Water evaporates into seemingly nothing, then returns as rain from clouds. Ice forms from liquid water and melts back again, demonstrating transformation between states. Water was the only substance readily observable in three distinct forms: solid, liquid, and vapor. If you are looking for a single substance that can become everything else, water is an excellent candidate based on observation. The reasoning was not random mysticism, but empirical inference, even if the conclusion was ultimately incorrect. The deeper philosophical importance lies not in water specifically, but in the concept of the arche. Arche is a Greek term meaning origin, beginning, first principle, or fundamental source. To seek an arche is to seek that which explains everything else, while itself requiring no further explanation. This is the structure of all subsequent scientific theorizing. Physicists seeking a theory of everything are seeking an arche in exactly this sense. Biologists tracing life to chemistry and chemistry to physics follow this same reductive explanatory pattern. Thales proposed that the universe has an arche and that humans can discover it through investigation. This is the founding assumption of naturalism, the view that nature is self-contained and self-explanatory. Before Thales, explanations typically terminated in the will of a god, which meant explanation stopped there. After Thales, explanation could continue until reaching some fundamental principle of nature itself. The gods did not disappear from Greek religion, but they were no longer necessary for explaining natural events. This intellectual liberation is what Aristotle recognized when he called Thales the founder of natural philosophy. A crucial element often misunderstood concerns his relationship to the divine. Thales reportedly said that all things are full of gods. Many assume this contradicts his naturalism or reveals residual mythological thinking. The evidence suggests something more subtle and more interesting philosophically. When Thales spoke of gods here, he was not referring to the personal Olympian deities of Greek religion. He was suggesting that the natural world itself possesses animating, moving, ordering principles that deserve reverent attention. Aristotle tells us that Thales believed the magnet has a soul because it causes iron to move. For Thales, soul meant simply the capacity to initiate motion, nothing more metaphysically elaborate. If something can cause movement without being pushed, it has soul in this technical sense. The lodestone pulls iron without any visible mechanism, so it must possess an internal principle of motion. This view is called hylozoism, the doctrine that matter is inherently alive or animated. Hyl means matter and zoe means life. So hylozoism literally means matter-life. This position stands between pure materialism and religious supernaturalism in an interesting way. Pure materialism treats matter as entirely passive, moved only by external forces. Religious supernaturalism treats matter as dead stuff moved by immaterial spirits or gods from outside nature. Hylozoism treats matter as inherently active, self-moving, possessing its own internal principles of change. This was a genuine third option that influenced philosophy for centuries. The Stoics, Renaissance nature philosophers, and even some contemporary panpsychists work in this tradition. The claim that all things are full of gods meant that divinity was immanent in nature, not transcendent above it. The water that constitutes all things was itself divine, not created or controlled by a separate divine being. This represents a radical theological move, identifying the divine with the natural order rather than separating them. There is no need to propitiate Zeus for rain if water itself follows natural laws of evaporation and condensation. Religious practice might continue as cultural tradition, but it was no longer intellectually necessary for explanation. Thales had begun the process of disenchanting the world that would culminate in modern naturalistic science. His other famous claim was that the earth floats on water like a piece of wood. This was his explanation for earthquakes, which he attributed to disturbances in the cosmic ocean supporting the earth. The flat earth floats on a vast body of water, and when that water becomes turbulent, the earth shakes. Again, this is factually wrong, but methodologically significant. It offers a natural mechanism for earthquakes rather than attributing them to an angry Poseidon striking the ground. Prediction becomes possible in principle because water turbulence might follow patterns discoverable through observation. What distinguished Thales from mythology was not just different content, but different structure of explanation. Mythological explanations invoke agents with wills, preferences, and emotional reactions. Such explanations are narratively satisfying but scientifically useless because agent behavior cannot be predicted systematically. Thales offered explanations in terms of substances, properties, and processes. Water has certain properties that make certain outcomes follow necessarily or probably. This is the logic of mechanism, of natural law, of science itself. The full significance of this shift only becomes clear when compared with preceding intellectual frameworks. The Babylonians had accumulated centuries of astronomical observations without explaining anything. They recorded patterns and made predictions, but never asked why the patterns existed. The Egyptians had practical geometry for land surveying and pyramid construction, but never developed theoretical mathematics. Thales took both Babylonian data and Egyptian techniques and asked, "What lies beneath?" He sought not just to describe, but to explain, not just to predict, but to understand. This is why Aristotle identified Thales as the beginning of philosophy and why that judgment remains defensible. Others before him were wise in practical matters and skilled in technical applications. Thales was the first we know of who sought systematic theoretical understanding of nature as a whole. His question about the fundamental substance assumed that such understanding was possible and worth pursuing. That assumption proved more important than his specific answer about water. Every physicist who seeks unified field theories works under assumptions Thales introduced 26 centuries ago. Part 2. The Epistemological Revolution. Before Thales, knowledge meant something fundamentally different than what it means after him. The primary sources of truth were tradition, authority, and divine revelation through oracles and priests. Homer and Hesiod were not just poets, but repositories of knowledge about gods, nature, and human affairs. To know something meant to have received it from a reliable source in an unbroken chain of transmission. The question was not whether a claim was true, but whether it came from authoritative origins. This epistemological framework made innovation inherently suspicious because new ideas lacked ancestral backing. Thales introduced a different standard. A claim is justified by the reasons supporting it, not its source. This seems obvious now only because his revolution succeeded so completely we cannot think otherwise. But consider how radical this was in a world where questioning tradition meant questioning the gods themselves. Thales said, in effect, that even the wisest ancestors could be wrong if their reasons were bad. Conversely, even a nobody with good observations and sound reasoning could discover genuine truth. Knowledge became democratic in principle, available to anyone willing to observe carefully and think rigorously. The shift involved three distinct epistemological moves that deserve separate examination. First, observation replaced revelation as the primary source of information about the natural world. You learn about water not by consulting priests, but by watching water in its various behaviors. This seems trivially true until you realize that most cultures never made this move independently. The default human epistemology trusts testimony from high-status sources over personal observation. Thales inverted this hierarchy, privileging what anyone can see over what authorities proclaim. Second, reasoning replaced tradition as the method of moving from evidence to conclusions. Observation alone gives you only particular facts about specific instances you have witnessed. To reach general conclusions about all water or the nature of reality requires inference. Thales modelled a form of inference we now call abduction, or inference to the best explanation. Given these observations about moisture, life, change and transformation, what explains them most economically? Water as fundamental substance explains the observed patterns better than any alternative he could conceive. Third, explanation replaced description as the goal of intellectual inquiry. The Babylonians had accumulated centuries of astronomical data with remarkable precision and reliability. They could predict eclipses, planetary positions, and seasonal changes with impressive accuracy. But they never asked why these patterns existed or what underlying structure generated them. For Babylon, the patterns simply were, perhaps reflecting divine will, perhaps just brute cosmic facts. Thales wanted to know what caused the patterns, what mechanism produced the regularities we observe. This explanatory ambition required a new conception of what counts as a satisfying answer to a question. In mythological thinking, citing a god's action terminates inquiry because gods are ultimate agents. Why does the sun move across the sky? Because Helios drives his chariot from east to west daily. This answers the question by identifying an agent whose will produces the phenomenon. But it does not explain why Helios does this or what mechanism makes the chariot move. Agent explanations push the mystery back one level without dissolving it. Thales sought explanations that dissolved mysteries by showing phenomena as necessary consequences of underlying structures. If all things are water and water naturally transforms under certain conditions, then we understand why things happen. The explanation lies in the nature of the substance itself, not in the arbitrary choices of a supernatural agent. This is the logic of natural law. Given the nature of things, certain outcomes must follow. Prediction becomes possible because nature is lawful, and understanding becomes possible because laws are intelligible. This conception of explanation remains the foundation of all natural science 26 centuries later. A subtle but crucial epistemological point concerns the role of simplicity in theory choice. Thales did not merely claim that water was important or prevalent in natural processes. He claimed that water was the single fundamental substance underlying all apparent diversity. This commitment to explanatory parsimony, to explaining more with less, became a hallmark of scientific thinking. The best explanation is not merely one that accounts for the data, but one that does so simply. Modern physicists seeking unified field theories operate under the same Thalian assumption about simplicity and truth. Why should simplicity be a guide to truth? This is a deep epistemological question with no easy answer. One possibility is pragmatic. Simpler theories are easier to test, apply, and refine through further investigation. Another is metaphysical. Reality itself is unified at some fundamental level, so true theories must reflect this. A third is cognitive. Our minds are finite, so we must seek comprehensible patterns in overwhelming complexity. Thales likely held the metaphysical view that reality truly is one beneath appearances of multiplicity. But whatever the justification, his methodological commitment to simplicity proved enormously productive. The epistemological revolution also involved a new attitude toward error and correction. Traditional knowledge systems resist correction because their authority derives from age and transmission fidelity. To admit error is to break the chain connecting present knowledge to authoritative ancestral sources. Thales implicitly invited correction by grounding his claims in reasons rather than pedigree. If the reasons are bad, the conclusion should be rejected regardless of who proposed it. His successors Anaximander and Anaximenes took this invitation seriously and modified his water thesis substantially. This self-correcting structure is what distinguishes science from dogma at the deepest level. Dogmatic systems treat their foundational claims as beyond question, immune to revision. Scientific systems treat all claims as provisional, subject to revision in light of better evidence and reasoning. Thales initiated this provisional self-correcting approach by showing that knowledge could advance through criticism. The Milesian school he founded was the first research program in history, with successive thinkers building on predecessors. This collaborative, cumulative structure of inquiry was itself a Thalian innovation of lasting significance. Part 3. The Metaphysics of the One. Thales claimed that all things are water, but what exactly does this claim mean philosophically? There are at least 3 distinct interpretations, each with different metaphysical implications. First, water might be the origin from which all things arose at some initial cosmic moment. Second, water might be the substrate that persists through all transformations as their underlying material. Third, water might be what all things really are beneath their misleading surface appearances. These interpretations are not equivalent and lead to very different philosophical positions. The originative interpretation treats water as the cosmic starting point, the primordial stuff from which differentiation began. On this view, the universe was once entirely water, and other substances emerged through transformation over time. Fire, earth, air, and all composite things develop from water through natural processes of change. But once developed, they may no longer be water in any meaningful sense. Your body originated from water ultimately, but is not currently water in its manifest properties. This interpretation makes the claim primarily cosmogonic, about the history of the universe rather than its present structure. The substrate interpretation treats water as the persistent material that remains through all transformations. When water becomes ice, the ice is water in a different state. When water evaporates, the vapor is water in a different form. Perhaps all apparent changes are similarly water-taking on different configurations while remaining fundamentally water. This interpretation makes the claim primarily about persistence through change, about what stays the same when things differ. It implies that destruction is impossible because water cannot be annihilated, only reconfigured. The identity interpretation is the strongest and most philosophically interesting version of the thesis. It claims that all things are water right now, despite appearing to be other substances. The rock, the tree, the fire, the air are all really water in disguise, water with different surface properties. Appearance and reality diverge radically, with apparent multiplicity masking underlying unity. This interpretation implies a strong metaphysical monism about the fundamental constitution of reality. Only water truly exists. Everything else is water appearing under different descriptions or modifications. Friedrich Nietzsche recognized the profound significance of this monistic move in his analysis of Greek philosophy. He noted that Thales's claim seems absurd on its surface, but contains deep insight. It tells us something about origins. It uses language without mythological imagery, and it contains embryonically the thought that all is one. The third point is philosophically decisive for Nietzsche. Thales glimpsed that beneath phenomenal diversity lies noumenal unity, that multiplicity is somehow illusory or derivative. This insight would echo through Western philosophy, from Parmenides through Spinoza to modern physics. The metaphysical problem of the one and the many is perhaps the deepest question in philosophy. How can one thing become many things, or many things be one thing at a deeper level? If water is truly one substance, how does it generate the many different kinds of things we observe? If it cannot really generate genuine multiplicity, then the multiplicity must be apparent rather than real. But if it can generate genuine multiplicity, then we need an explanation of how unity produces plurality. Thales posed this problem clearly, even if he could not solve it satisfactorily. The problem cuts deeper when we consider qualitative diversity in addition to numerical multiplicity. Even granting that many things could come from one substance, how do different kinds of things emerge? Water is wet, cold, fluid, and transparent, but fire is dry, hot, flickering, and visible differently. How does a wet thing produce a dry thing? A cold thing produce a hot thing? The qualitative opposition between elements seems to resist derivation from any single element. This objection would later motivate Anaximander to posit an indefinite source rather than any specific element. One possible Thalian response appeals to the transformative properties of water specifically. Water is unique among familiar substances in being observable in three radically different states. Solid ice, liquid water, and gaseous vapour differ dramatically in their manifest properties. Ice is hard and rigid. Liquid water flows and takes container shapes. Vapour is invisible and expansive. If one substance can exhibit such different properties under different conditions, perhaps all differences arise similarly. Temperature, pressure, and other conditions might determine which properties water manifests at any moment. This response anticipates in primitive form the modern distinction between substance and properties. A single underlying substance can possess or manifest different properties under different circumstances. The properties are real, but the substance beneath them is more fundamental than any particular property it displays. Water remains water, whether solid, liquid, or gaseous. Only its properties change, not its nature. Perhaps all apparent diversity is water manifesting different properties rather than different substances existing. This philosophical move toward underlying unity beneath surface diversity proved permanently influential. The reduction of many to one also serves important explanatory and cognitive functions. A world with unlimited fundamental kinds of things would be incomprehensible, impossible to systematize or understand. If every distinct thing required its own unique explanation, science could never achieve general laws. By positing that all things share a common nature, Thales made systematic knowledge of nature possible. We can understand water and thereby understand everything, because everything is water understood differently. This is the faith that underlies all reductive scientific programs. Complexity reduces to simplicity at some level. Modern physics continues this Thalian program with different candidate unifiers. Atoms, then subatomic particles, then quarks and leptons, then possibly strings or quantum fields. Each reduction proposes a simpler level underlying the more complex level we observe directly. The goal remains Thalian. Find the one from which the many derive. Whether this goal is achievable or even coherent remains debated, but its origin is clear. Thales first proposed that reality admits of ultimate reduction, and science has never stopped trying. Part 4. The problem of change. If all things are water, then change becomes a profound puzzle requiring explanation. When water becomes ice, we say the same substance has changed its properties. But when the Greek heroes become the Greek gods, become the natural forces, we seem to have different stories. Thales needed to explain how one thing becomes another while remaining fundamentally the same thing. This is the problem of change, the question of how persistence and transformation relate. It would haunt Greek philosophy for 3 centuries and remains debated in contemporary metaphysics. Consider first the logical structure of change and why it presents philosophical difficulties. For change to occur, something must be different at one time than it was at another time. But if the thing is truly different, then it seems to be a different thing, not the same thing changed, and if it is truly the same thing, then nothing about it has changed, and no change has occurred. Change seems to require both identity and difference simultaneously with respect to the same entity. How can one thing be both the same and different without contradiction? Thales's water thesis provided one framework for addressing this puzzle through substance and attributes. Water is the substance that persists through change. Its properties are the attributes that vary. When water freezes, the substance remains, but the attributes of fluidity and temperature change. Identity is preserved at the level of substance, while difference occurs at the level of attributes. Change is not a thing becoming a different thing, but the same thing gaining or losing properties. This substance-attribute ontology became enormously influential in subsequent philosophy and theology. But this solution raises further questions about the relationship between substance and its attributes. Can we even conceive of water apart from all its properties as pure, bare substance? When we remove fluidity, temperature, colour, taste, and all other attributes, what remains to call water? It seems we cannot think of substance except through its properties, as the bearer or possessor of them. Yet if substance just is its properties, then when properties change entirely, the substance changes too. The very notion of underlying substance becomes problematic upon close examination. Another puzzle concerns the mechanism of transformation rather than just its logical structure. Granting that water can transform, what causes it to transform at any particular moment? Why does water become ice here and now rather than remaining liquid or becoming vapour. The bare substance of water does not explain the direction or timing of any specific change. We need principles of change, forces or tendencies that govern which transformations occur when. Thales apparently did not develop such principles systematically, leaving the problem for his successors. Anaximander recognized this gap and proposed that change occurs through the interaction of opposites. Hot and cold, wet and dry, light and dark are opposed forces that generate change through conflict. When hot predominates, things warm. When cold predominates, things cool. Change is the outcome of cosmic struggle between opposed principles or powers. This opposition theory explained why change occurs and in which direction at any moment. It supplemented Thales's account of what changes with an account of how and why it changes. But if opposites drive change, then the fundamental reality cannot be any single element. Water is wet, so it stands on one side of the wet and dry opposition. It cannot be the source of dryness because it is essentially opposed to dryness. Anaximander concluded that the arche must be unlimited or indefinite, not any specific element. The boundless or apeiron, from which all things emerge, must be neutral between opposites to generate them all. This was a direct critique of Thales's choice of water as the fundamental substance. The problem of change also raises the question of temporal continuity through transformation. If water becomes earth over time, is there a moment when it ceases being water and starts being earth? Or does the transition happen gradually with no sharp boundary between the two states? If gradual, then there must be intermediate states that are neither clearly water nor clearly earth. What should we call these intermediates, and how do they fit into a theory with only one substance? The logic of continuous change creates puzzles that discrete categorization schemes cannot easily handle. Later, Greek philosophers developed different responses to these Thalian puzzles about change. Heraclitus embraced change as the fundamental reality, claiming that everything flows and nothing remains fixed. Parmenides denied change altogether, arguing that true reality is unchanging and apparent change is illusion. Plato distinguished between a changing sensible world and an unchanging realm of eternal forms. Aristotle developed the concepts of potentiality and actuality to explain how change is logically possible. All these positions were responses to problems that Thales's monism had first clearly revealed. The question of how one thing becomes many things connects to fundamental physics today. The Big Bang theory posits an initial state of extreme simplicity from which cosmic complexity emerged. How did a hot, dense, nearly uniform plasma become galaxies, stars, planets, and living organisms? Physics describes the mechanisms through symmetry breaking, phase transitions, and emergent complexity. But the philosophical puzzle remains. How does genuine novelty arise from what contained no such novelty? Thales's question about water becoming not water prefigures every scientific question about cosmic evolution. Part 5. The Invention of Proof. Thales is credited with introducing deductive proof into mathematics, a contribution possibly more consequential than his philosophical doctrines. Before him, mathematical knowledge was empirical, based on measurement, observation, and pattern recognition. The Egyptians knew many geometric facts useful for surveying land and constructing pyramids, but they knew these facts as recipes that worked, not as truths that had to be so. Thales transformed mathematics from a collection of useful techniques into a system of demonstrated certainties. This invention of proof changed not only mathematics, but the very conception of what knowledge could be. A proof is an argument that shows a conclusion follows necessarily from accepted premises. If the premises are true and the reasoning is valid, the conclusion cannot be false. This differs fundamentally from empirical evidence, which shows only that something has been true so far. No amount of observation can prove that the sun will rise tomorrow with absolute certainty. But a deductive proof establishes its conclusion beyond all possible doubt for all times and places. The certainty of mathematics derives from this deductive structure that Thales introduced to Greece. The earliest theorem attributed to Thales seems disappointingly simple. A diameter bisects a circle. This statement appears obvious to the point of triviality once you understand what the words mean. But that apparent triviality is precisely what made it revolutionary as an object of proof. Thales asked, "Can we demonstrate that this must be true? Not merely observe that it appears true." The answer required showing that the statement follows necessarily from the definition of circle and diameter. A circle is the set of all points equidistant from a centre. A diameter passes through that centre. The proof proceeds by considering what would happen if the diameter did not bisect the circle equally. If one half were larger than the other, some points would be farther from the centre than others. But that contradicts the definition of circle as points equidistant from the centre. Therefore, the assumption that the halves are unequal must be false, and they must be equal. This is proof by contradiction, showing that denying the conclusion leads to absurdity. Thales discovered that you could establish positive truths by demonstrating that their negations are impossible. Several other geometric theorems are attributed to Thales with varying degrees of historical reliability. The base angles of an isosceles triangle are equal to each other. Vertical angles formed by two intersecting lines are equal. Two triangles are congruent if they share two angles and the side between them. An angle inscribed in a semicircle is a right angle of 90 degrees. Reportedly, Thales sacrificed an ox to the gods in gratitude upon discovering this last theorem. The significance lies not in any individual theorem, but in the idea that theorems could be proven. Each proof demonstrated that mathematical truths were not arbitrary conventions or lucky observations. They were necessary truths that held universally because they followed from definitions and prior truths. Mathematics became the first domain where human beings achieved certain knowledge as opposed to probable opinion. This contrast between demonstrative certainty and empirical probability shaped philosophy for millennia. Plato's entire epistemology privileged mathematical knowledge as the paradigm that other knowledge should emulate. The cognitive technology of proof required several conceptual innovations working together. First, explicit definitions, that fix the meaning of terms precisely rather than relying on intuitive understanding. You cannot prove anything about circles until you define exactly what a circle is. Second, identification of axioms or starting points accepted without proof as the foundation for demonstrations. Third, logical rules, specifying which inferences validly move from premises to conclusions. Thales initiated this framework that Euclid would later systematize magnificently in his Elements. Proof also required a new attitude toward obvious truths that deserved demonstration despite their apparent self-evidence. Why bother proving that a diameter bisects a circle when anyone can see that it does? Because seeing is not the same as understanding, and understanding requires grasping why something must be so. Proof reveals the structure of mathematical truth, the dependencies between propositions. We understand the theorem not as an isolated fact, but as connected to definitions and other theorems. This systematic interconnection of truths through proof created mathematics as a unified body of knowledge. The philosophical implications of proof extended far beyond mathematics into epistemology and metaphysics. If some truths could be known with certainty through pure reason, perhaps reality itself had rational structure. The universe might be organized according to intelligible principles that mind could grasp without sensory observation. This rationalist hope that reason alone could penetrate to the nature of things drew power from mathematical proof. The success of demonstration in geometry suggested that demonstration might succeed in understanding nature itself. Thales's philosophical claims about water being fundamental were attempts at such demonstrative natural philosophy. Modern mathematics has vastly extended the domain of proof while also revealing its limitations. Gödel showed that any sufficiently powerful formal system contains truths it cannot prove. This incompleteness theorem indicates that proof cannot capture all mathematical truth, contrary to earlier hopes. Yet within its domain, proof remains the gold standard of certainty that Thales first established. Every mathematical result published today must meet standards of rigorous demonstration he initiated. The practice of proof is a 26th-century-old tradition beginning in Miletus with a theorem about circles. Part 6. Measuring the Unmeasurable. Ancient sources credit Thales with remarkable feats of practical measurement that illustrate his intellectual methods. He reportedly calculated the height of the Egyptian pyramids using shadows and proportional reasoning. He allegedly determined the distance of ships from shore without any direct measurement of the water between. These achievements, whether historical or legendary, embody the conceptual revolution he represented. They show how abstract reasoning about relationships could yield knowledge that direct measurement could not provide. The unmeasurable became measurable through the mediation of geometric principles. The pyramid measurement works as follows according to the accounts we have. Thales waited until the moment when his own shadow equaled his own height exactly. At that precise moment, the shadow of any vertical object equals the height of that object. The pyramid's shadow at that moment, therefore, equals the pyramid's height. By measuring the accessible shadow on the ground, he obtained the inaccessible height in the sky. A relationship between his body and its shadow transferred to the pyramid and its shadow. This solution requires recognizing that the sun illuminates all objects at the same angle simultaneously. The ratio between any object and its shadow is constant across all objects at any given moment. When that ratio happens to be 1:1, heights and shadow lengths become interchangeable measurements. Thales grasped this general principle and applied it to solve a specific practical problem. The move from particular observations to general principles to specific applications defines scientific reasoning. He demonstrated this pattern clearly enough that later writers considered him the originator of such methods. The ship distance measurement uses similar triangles in a more sophisticated geometric construction. From a point on shore, you measure angles to a ship and to another point on the shore. By constructing similar triangles on land, using these angles, you create a scale model of the situation. The ratio of distances in your accessible land triangle equals the ratio in the inaccessible sea triangle. Measuring your constructed triangle tells you the distance to the ship through proportional reasoning. Again, a relationship you can investigate directly transfers to a relationship you cannot investigate directly. The underlying principle is that geometric relationships are invariant under scaling and similar transformations. A triangle with certain angle measures has those same angles regardless of how large or small it is. The ratios between sides remain constant even as absolute lengths change. This invariance allows you to study an accessible small version to learn about an inaccessible large version. The small model and large reality share the same abstract geometric structure despite differing in size. Thales exploited this structural correspondence between models and reality in his measurement techniques. The philosophical significance transcends the practical utility of measuring pyramids and ship distances. Thales showed that indirect knowledge was possible through reasoning about relationships and structures. You can know things about objects you have never touched, measured directly, or even approached closely. The world has a rational structure that thought can penetrate even where perception cannot reach. This opens the possibility of knowledge about entities too large, too small, too distant, or too hidden for direct observation. All theoretical science rests on this Thalian confidence in indirect knowledge through structural reasoning. Consider how modern physics knows about black holes, quarks, and the early universe. No one has directly perceived any of these objects or events. Knowledge comes through indirect reasoning from observable effects to unobservable causes, using theoretical principles. The logic is structurally identical to Thales measuring pyramids through shadows. An accessible phenomenon stands in knowable relationships to an inaccessible phenomenon of interest. By investigating the accessible phenomenon and understanding the relationship, we gain knowledge of the inaccessible. The intercept theorem, also attributed to Thales, makes the geometric foundation explicit. If a line is drawn parallel to one side of a triangle, it divides the other two sides proportionally. This theorem about proportional division underlies all the measurement applications we have discussed. It shows that parallel structures create corresponding ratios across different scales and contexts. Once you know this principle, you can apply it to countless particular problems involving inaccessible distances. The general theorem is more powerful than any finite collection of particular measurements could be. Thales also reportedly advised sailors to navigate by Ursa Minor rather than Ursa Major for greater accuracy. This astronomical navigation guidance required understanding how celestial objects move relative to geographic positions. Ursa Minor contains Polaris, the North Star, which remains nearly fixed while other stars rotate around it. Steering by a fixed point is more reliable than steering by moving points that require constant recalculation. This practical advice reflected theoretical understanding of celestial mechanics and their terrestrial applications. The man who measured pyramids with shadows also measured the heavens for seafarers. Part 7. Celestial Mechanics. The most famous story about Thales is that he predicted a solar eclipse that occurred on May 28, 585 BCE. This eclipse allegedly stopped a battle between the Lydians and the Medes, who took it as an omen. If Thales truly predicted this eclipse, it would demonstrate remarkable astronomical knowledge for his era. However, modern scholars are deeply divided about whether he could have made such a prediction with available methods. The story, nevertheless, reveals important truths about his astronomical interests and their philosophical significance. Whether fact or legend, it shows what his contemporaries considered possible for natural philosophy to achieve. Solar eclipse prediction requires knowing the cycles governing the relative positions of Sun, Moon, and Earth. The Babylonians had discovered the Saros cycle of approximately 18 years between similar eclipses. By tracking eclipses over generations, they could predict that an eclipse was likely in a given period. But predicting exactly when and where an eclipse would be visible required calculations they could not perform. Thales might have used Babylonian eclipse records to predict an eclipse would occur in a particular year. Predicting the exact day and location of visibility seems beyond the astronomical knowledge then available. Modern analysis of the 585 BCE eclipse confirms it was total and visible in the region of the battle. The timing aligns with the historical accounts of the Lydian and Median conflict. This suggests the eclipse story has some historical foundation rather than being purely legendary. But Thales may have been lucky, predicting an eclipse for the right year, without knowing the exact day. Alternatively, the story may have grown in the telling, with later writers attributing more precision than Thales claimed. Scholarly honesty requires acknowledging this uncertainty about what exactly Thales achieved astronomically. The philosophical significance of eclipse prediction lies in what it implies about celestial regularity. If eclipses can be predicted, they follow natural laws rather than expressing divine whims. An angry god might eclipse the sun at any moment for inscrutable reasons, making prediction impossible. Successful prediction proves that celestial events follow patterns that human reason can discover and utilize. The heavens are not arbitrary, but lawful, not capricious, but regular, not divine mystery, but natural order. This demystification of the sky was philosophically revolutionary, regardless of Thales's specific predictive success. Thales reportedly worked on determining the dates of solstices and equinoxes with improved accuracy. The solstices are the longest and shortest days of the year when the sun reaches its extreme positions. The equinoxes are the days when day and night are equal, with the sun crossing the celestial equator. Accurate determination of these dates mattered for agriculture, navigation, and calendar systems. By improving solstice calculations, Thales provided practical benefits while advancing astronomical understanding. He also reportedly studied the apparent size of the Sun, estimating it at 1/720th of its circular path. Ancient sources also credit Thales with recognizing that the Moon shines by reflected light from the Sun. This seems obvious now, but required insight in an era that treated celestial bodies as fundamentally different from terrestrial objects. If the Moon reflects sunlight, then it is a physical body illuminated from outside, not a source of its own light. This physical understanding of the Moon opened possibilities for explaining lunar phases and eclipses mechanically. The Moon's cycle of phases results from its changing angle relative to Sun and Earth. Eclipses occur when Sun, Moon, and Earth align to block light, rather than because gods send omens. The naturalization of celestial phenomena was perhaps Thales's most culturally disruptive contribution. Ancient peoples universally treated the sky as sacred, the dwelling place of gods and repository of divine signs. Astronomy was inseparable from astrology, the reading of divine messages in celestial configurations. By treating eclipses and solstices as natural events following discoverable patterns, Thales desacralized the heavens. The sky became another part of nature to be investigated rather than worshipped and propitiated. This move made modern astronomy possible by removing celestial phenomena from theological interpretation. Yet Thales did not entirely separate astronomy from theology in the way modern science would later do. He apparently believed that celestial bodies were divine in some sense, perhaps alive or ensouled. Their regularity expressed not mechanical indifference, but cosmic intelligence or ordering principles. The gods had not disappeared, but transformed into natural forces exhibiting lawful behavior. This position occupies a transitional space between pure mythology and pure naturalism. It preserved some sense of cosmic meaning while abandoning explanations through anthropomorphic divine agency. The question of celestial mechanism versus celestial purpose remained live through Greek philosophy. Plato treated celestial motions as expressions of divine reason, perfect and eternal, unlike chaotic terrestrial change. Aristotle distinguished celestial matter from terrestrial matter, with different physics governing each realm. Only with the Copernican revolution did celestial and terrestrial physics finally unify under common laws. But the possibility of such unification depended on Thales's prior naturalization of celestial phenomena. He showed that the sky could be studied with the same rational methods applied to earthly events. Part 8. The Living Cosmos. Thales believed that all things are full of gods, and that the magnet possesses a soul because it moves iron. These claims seem to reintroduce supernatural elements after his supposed naturalistic revolution. But properly understood, they represent a sophisticated metaphysical position called hylozoism. Hylozoism holds that matter is inherently alive or animated, not dead stuff moved by external forces. This view differs from both pure materialism and religious supernaturalism in ways worth examining carefully. Thales's hylozoism profoundly influenced subsequent philosophy and anticipates contemporary debates about consciousness. The key term requiring analysis is soul, which meant something different to Greeks than to later Christians. For Thales and his contemporaries, soul was simply the principle of motion or life in things. To have a soul meant to have the capacity for self-movement, for initiating change without external push. Living things obviously have souls because they move themselves from within rather than requiring external movers. A dead body differs from a living body precisely in losing this internal principle of motion. Soul is not primarily about consciousness, reason, or immortality, but about the capacity for self-originating activity. Given this definition, Thales observed that magnets exhibit soul-like properties despite being mere stones. A lodestone moves iron toward itself without any visible mechanism, without being pushed by anything external. It seems to attract iron through some internal power, analogous to how animals attract food to themselves. If soul is the principle of self-originating motion, and magnets originate motion toward iron, then magnets have souls. The reasoning is valid given Thales's definition of soul, even though we now explain magnetism differently. He was not being mystical, but applying his concept of soul consistently to observed phenomena. The same analysis applies to amber, which when rubbed attracts light objects like straw and feathers. This is the phenomenon of static electricity, though Thales had no such theoretical framework. What he observed was attraction without contact, action across empty space with no visible intermediary. Such attraction seemed to require something like desire or will, some internal principle moving toward objects. If amber can reach out and pull things toward itself, it possesses something like the striving we see in living things. The Greek word for amber, electron, eventually gave us the word electricity from these observations. Thales generalized from magnets and amber to the cosmos as a whole, claiming all things are full of gods. This statement is best interpreted as claiming that animating principles pervade all of nature. Motion and change exist everywhere, so the soul that causes motion and change must exist everywhere. The universe is not dead matter occasionally pushed by external divine forces. It is living matter possessing internal principles of activity that drive all natural processes. The gods here are immanent forces rather than transcendent personal beings intervening from outside nature. This hylozoic view solves an important problem about the source of motion in a monistic system. If all things are water, where does the motion that transforms water into other states come from? An external mover would violate monism by introducing something other than water into the explanatory system. But if water itself is inherently active, possessing internal principles of motion, no external mover is needed. The transformations of water into earth, air, and fire are expressions of water's own internal dynamism. Hylozoism provides the motive principle that pure materialism about inert matter cannot supply. Later, philosophers divided on whether to accept this hylozoic solution to the motion problem. The atomists Leucippus and Democritus kept matter but made it inert, with motion being eternal and unexplained. Plato introduced an immaterial soul as the source of motion, separate from and superior to matter. Aristotle tried to combine insights from both, with form as the internal principle of motion within matter. But all were responding to the problem Thales had posed about where motion comes from in a natural universe. His hylozoic solution remained a live option that periodically resurfaced in Western thought. Renaissance nature. Philosophers revived hylozoism against the mechanical philosophy emerging in early modern science. Giordano Bruno, Paracelsus and others saw nature as animated throughout by vital forces or world soul. They resisted the picture of nature as dead clockwork mechanism operated by mathematical laws alone. For them, Thales's vision of living matter was truer to observed phenomena than Cartesian mechanism. The mechanist victory was not foreordained and depended on pragmatic success rather than philosophical proof. Hylozoism lost because mechanism proved more productive for physics, not because it was definitively refuted. The deepest question raised by hylozoism concerns where life itself comes from in a physical universe. If matter is fundamentally dead and inert, how did living things ever arise from non-living precursors? The origin of life problem remains unsolved in contemporary biology, and hylozoism offers one framework. Perhaps life did not emerge from matter, but was always present in matter in some form. This would dissolve the origin problem by denying the premise that matter was ever truly lifeless. Thales's claim that all things have soul becomes a hypothesis about the fundamental nature of physical reality. Part 9. Mind in Matter. Hylozoism about life and motion leads naturally to harder questions about mind and consciousness in matter. If all things have soul in the sense of self-moving power, do all things also have experience? Is there something it is like to be a magnet, an amber stone, or a droplet of water? These questions define the contemporary position called panpsychism, the view that mind pervades nature. Thales's statements about soul and gods suggest he held a proto-panpsychist position worth examining. The standard modern view treats consciousness as emerging from complex information processing in brains. Simple matter has no experience. Only sufficiently complex organized matter becomes conscious. But this creates the notorious hard problem of consciousness, articulated by philosopher David Chalmers. How does subjective experience arise from objective physical processes that seem entirely different in nature? No amount of describing neural firings seems to explain why there is something it is like to see red. The gap between physical description and conscious experience seems unbridgeable by any functional or structural account. Panpsychism offers a radical solution. Consciousness does not emerge from matter because matter always had consciousness. Experience is a fundamental feature of reality, like mass or charge, not a derivative phenomenon requiring explanation. Complex consciousness in brains results from combination or organization of simpler consciousness in components. This avoids the hard problem by denying that consciousness ever arose from something entirely non-conscious. The transition is from simple experience to complex experience, not from no experience to some experience. Thales's claim that all things are full of gods anticipates this panpsychist move by millennia. The combination problem challenges panpsychism. How do micro-experiences combine into unified macro-experience? Even granting that electrons have some minimal experience, how does my unified visual field arise from them? The experiences of billions of particles do not obviously sum to a single coherent experience of a conscious subject. Critics argue that panpsychism merely trades the hard problem for an equally hard combination problem. Defenders respond that combination seems more tractable than emergence from zero consciousness. The debate continues with no consensus, but Thales's intuition that mind pervades nature motivates serious contemporary positions. A different interpretation of Thales emphasizes intelligence or order in nature rather than subjective experience. When he says all things are full of gods, he may mean that rational principles govern all natural processes. The regularity of celestial motions, the patterns of elemental transformation, the structures of geometry all exhibit order. This order suggests mind-like organization pervading the cosmos without requiring that each particle feels something. The universe is rational in the sense of being intelligible, structured according to principles thought can grasp. This cosmic rationalism differs from panpsychism while preserving some of Thales's intent. The relationship between Thales's water thesis and his psychic thesis deserves attention. If water is the fundamental substance and all things are full of soul, then water itself must be ensouled. The transformations of water into various forms would then be expressions of water's internal psychic activity. Water does not passively receive changes from outside, but actively transforms itself from within. The cosmic waters are alive, purposive, perhaps even, in some sense, aware. This makes the universe more like an organism than a machine, more like a living body than dead matter. Ancient sources confirm that Thales did not consider his natural philosophy to exclude divinity, but to transform it. Diogenes Laertius reports that Thales considered God to be the mind of the world, the oldest of beings. God exists without external cause. The world is beautiful because God made it, and all things manifest divinity. This sounds more religious than the naturalistic image of Thales sometimes presented. But the God here is not Homer's Zeus, with human passions and moral failures. It is cosmic intelligence immanent in the natural order, what later philosophers would call the world soul. The question of mind in nature connects to deep issues about the relationship between physics and consciousness. Modern physics describes the world in entirely third-person objective terms without reference to experience. Yet we know consciousness exists because we experience it directly from the first-person perspective. How do the third-person world of physics and the first-person world of experience relate? Thales's position that all things have psychic properties suggests they are not two separate worlds, but one world with two aspects. Matter as known from outside and mind as known from inside might be the same reality, differently apprehended. This dual-aspect monism appears in later philosophers from Spinoza to contemporary thinkers like Bertrand Russell. Russell proposed that physics describes only the structure of matter, its relational properties and behaviors. The intrinsic nature of what has that structure remains unknown to physics and might be experiential. Consciousness is what matter is from the inside, while physical properties are how it appears from outside. This view preserves physicalism about structure while granting fundamental status to consciousness. Thales's intuition that the physical and the psychic are intimately connected finds sophisticated modern expression. Part 10. The Milesian Succession. Thales did not work in isolation, but founded what historians call the Milesian school of natural philosophy. His immediate successors were Anaximander and Anaximenes, both from Miletus, both extending and criticizing his ideas. This pattern of succession through critical engagement rather than mere transmission defines philosophy from its origin. Anaximander reportedly studied with Thales directly and became his intellectual heir. But inheritance meant transformation, and Anaximander's first major move was rejecting water as the fundamental substance. The history of philosophy begins with a student correcting his teacher through better arguments. Anaximander's objection to water was precise and powerful, targeting the logic of Thales's position. Water has definite qualities. It is wet, cold, fluid, and transparent under normal conditions. But the fundamental substance must generate all qualities, including those opposite to its own nature. How can something wet be the source of dryness, something cold be the source of heat? Water stands on one side of the fundamental oppositions that structure the natural world. It cannot be neutral enough to generate both sides of these oppositions without privileging one over the other. This objection reveals a deep constraint on any proposed arche or fundamental principle. The arche must be able to give rise to everything without being biased toward any particular outcome. If the arche is water, we would expect the universe to be predominantly wet and cold. But the universe contains fire, which is dry and hot, seemingly the opposite of water in every respect. Either water is not truly fundamental, or we need to explain how it generates its own opposites. Anaximander saw no satisfactory explanation available and concluded that water could not be the arche. His alternative proposal was the apeiron, a Greek term meaning the boundless, unlimited, or indefinite. The apeiron has no specific qualities that would bias it toward generating some things rather than others. It is neither hot nor cold, neither wet nor dry, neither any definite thing at all. From this indefinite source, all definite things emerge through a process of differentiation and opposition. Hot separates from cold, wet from dry, and these opposites then interact to produce the world we observe. The apeiron solves the problem of how one thing generates its opposite by being neither one nor the other. Anaximander also introduced the concept of cosmic justice, governing the interactions of opposed elements. In the only fragment of his writing that survives, he says things give penalty and retribution to each other for injustice. When hot encroaches too far on cold, a correction occurs, restoring balance. The world maintains itself through this continuous balancing of opposed forces according to necessity. This is among the first expressions of natural law, as opposed to divine whim governing cosmic events. Nature has its own internal principles of order that operate impersonally and universally. Anaximenes, the third Milesian, found Anaximander's Apeiron too abstract and explanatorily empty. How does something with no definite properties produce things with very definite properties? The indefinite seems to explain too much by explaining nothing specific about any particular phenomenon. Anaximenes wanted an arche that was both fundamental and capable of concrete explanatory work. He proposed AIR as the fundamental substance, partly returning to Thales's approach of selecting a specific element. But he added a crucial explanatory mechanism that neither Thales nor Anaximander had provided. The mechanism was condensation and rarefaction, the thickening and thinning of air. When air rarefies or thins out, it becomes fire, hot and bright and expansive. When air condenses slightly, it becomes wind, then cloud, then water, as condensation continues. Further condensation produces earth, and extreme condensation produces stones and metals. All qualitative differences reduce to quantitative differences in the density of a single substance. This was a major conceptual advance, explaining quality through quantity using a single continuous variable. Anaximenes could point to observable evidence for his condensation and rarefaction mechanism. Breath from an open mouth feels warm. Breath through pursed lips feels cool. The same air seems to change temperature depending on how compressed or expanded it is when exhaled. Clouds form when air rises and cools, condensing moisture that was invisibly distributed through it. Rain falls when condensation continues, and ice forms when condensation reaches an extreme. These everyday observations supported the theoretical mechanism Anaximenes proposed. The Milesian succession demonstrates philosophy progressing through dialectical criticism and response. Thales proposed water, Anaximander objected and proposed the Apeiron. Anaximenes objected and proposed air with a mechanism. Each position was more sophisticated than the last, incorporating lessons from previous failures. This cumulative, self-correcting structure distinguishes philosophy and science from dogmatic traditions. No Milesian simply accepted what his teacher said. Each thought independently and argued for improvements. The school was unified by shared questions and methods, not by shared doctrines requiring acceptance. What the Milesians shared was more important than their specific disagreements about which substance was fundamental. They all sought naturalistic explanations without appeal to anthropomorphic gods. They all believed in an underlying unity beneath apparent diversity. They all used observation and reasoning rather than revelation and tradition as sources of knowledge. They all considered the universe to be orderly and in principle comprehensible by human minds. These shared commitments constituted a research program that would develop over subsequent centuries. The Milesian achievement was creating a tradition of rational inquiry that could survive any individual's errors. Thales was wrong about water. Anaximander possibly wrong about the Apeiron. Anaximenes wrong about air. But the tradition they established kept developing, incorporating new insights and correcting old mistakes. This is what distinguishes live intellectual traditions from dead dogmas preserved unchanged. The Milesians invented not just specific theories, but the very practice of theoretical natural philosophy. We are their heirs whenever we ask what fundamental reality is and seek naturalistic answers through reason. Part 11. Through Aristotle's lens. Nearly everything we know about Thales comes through Aristotle, writing over 2 centuries after Thales lived. This creates profound problems for historical reconstruction that honest scholarship must acknowledge. Aristotle was not a neutral reporter, but a philosopher with his own systematic agenda and conceptual vocabulary. He interpreted his predecessors through categories they did not possess, and for purposes they did not share. Separating what Thales actually thought from what Aristotle attributed to him is extremely difficult. We must read our sources critically, recognizing their limitations and potential distortions. Aristotle's main discussion of Thales occurs in Book 1 of the Metaphysics, where he surveys earlier thinkers. His purpose is to show that previous philosophers groped toward truths he himself had fully articulated. They grasped parts of his fourfold causal analysis, but never achieved the complete picture. Thales and the Milesians understood material causation, what things are made of, but nothing more. This framing makes earlier thinkers appear as primitive precursors rather than independent intellects. Aristotle's narrative serves his own philosophical agenda, which may distort his predecessors' actual views. Consider Aristotle's claim that Thales chose water because all seeds are moist and all life requires moisture. Aristotle explicitly says he is conjecturing about Thales's reasons, not reporting what Thales himself said. The reasons Aristotle provides are plausible, but may not reflect Thales's actual thinking at all. We have Aristotle's reconstruction of why someone might hold Thales's position, not Thales's own arguments. This distinction between testimony and interpretation pervades all our sources on early Greek philosophy. We must constantly ask whether we are learning about Thales or about how later thinkers imagined Thales. The conceptual vocabulary Aristotle uses was not available to Thales and may misrepresent his ideas. Terms like arche, material cause, element, and principle had technical meanings in Aristotle's philosophy. Did Thales actually use the word arche, or is this Aristotle's terminology imposed retrospectively? When Aristotle says Thales sought the material cause, is he accurately describing Thales's project? Or is he translating Thales's thinking into an Aristotelian framework that changes its meaning? These questions have no certain answers, but ignoring them produces false confidence about what Thales believed. Later sources compound the problem by depending on Aristotle and adding their own interpretations and embellishments. Diogenes Laertius wrote in the 3rd century CE, roughly 800 years after Thales lived. His lives of eminent philosophers collect stories and sayings from various sources of varying reliability. Some material may trace back to authentic early traditions. Other material may be invention or confusion. Diogenes himself often could not distinguish reliable from unreliable sources in his compilation. We inherit his uncertainties along with his information, unable to check his sources independently. The doxographic tradition, the reporting of philosophical opinions, had systematic biases worth noting. Writers tended to assimilate earlier thinkers to later schools, finding Stoic or Platonic ideas in Presocratics. They also filled gaps in the record with plausible inventions based on what a thinker should have believed. Achievements multiplied over time as admiring successors credited founders with more and more discoveries. The Thales of later tradition may be considerably inflated compared to the historical Thales. Skeptical scholars argue we can know almost nothing certain about what Thales actually thought. Against this skepticism, some core claims appear consistently across independent source traditions. That Thales proposed water as fundamental, that he predicted an eclipse, that he was counted among the 7 sages. These claims appear early enough and widely enough to suggest some historical foundation. The specific details may be legendary, but the general picture of a pioneering natural philosopher seems secure. We can reasonably attribute to Thales the basic project of seeking natural explanations for phenomena. The specific arguments and doctrines remain more uncertain than the general intellectual orientation. Aristotle's testimony, despite its problems, remains invaluable because he had access to sources now lost. The early peripatetic school collected and studied pre-Socratic writings that no longer survive. Theophrastus, Aristotle's successor, wrote systematic accounts of earlier natural philosophy, now known only through fragments. When Aristotle reports what Thales said, he may be drawing on texts or reliable oral traditions we cannot check. Dismissing his testimony entirely would leave us with almost nothing to discuss. The best approach treats Aristotle as a valuable but imperfect witness requiring critical evaluation. The scholarly problem of sources teaches an important epistemological lesson about historical knowledge generally. We never have direct access to the past, but only to traces and reports filtered through intervening transmitters. Each transmitter introduces potential distortions based on their own interests, limitations, and contexts. Historical knowledge is therefore always probabilistic, always subject to revision as new evidence emerges. Certainty about what Thales thought is impossible. Reasonable confidence about his general project is achievable. This humility about historical knowledge reflects the Thalian spirit of inquiry better than dogmatic claims would. Part 12. The Naturalism Debate. A major scholarly controversy concerns whether Thales was genuinely a naturalistic thinker or whether this interpretation projects modern assumptions backward. The standard narrative treats him as breaking from mythological thinking toward rational scientific explanation. But some scholars argue this narrative reflects Enlightenment values more than 6th century BCE Greek reality. They suggest Thales remained embedded in religious and mythological frameworks, even while innovating within them. The debate matters because it concerns how we understand the origins of Western rationality itself. Was there a sharp break from myth to reason, or a gradual transformation with much continuity? Evidence for Thales's naturalism includes his search for material explanations without invoking anthropomorphic gods. He explained earthquakes through water movements rather than through Poseidon's anger. He sought regular patterns in celestial events rather than treating them as arbitrary divine signs. His choice of water as arche was based on observation and reasoning, not on sacred tradition or revelation. These features distinguish his approach from the mythological cosmogonies of Homer and Hesiod. The contrast seems clear enough to justify calling his approach naturalistic in some meaningful sense. Evidence against pure naturalism includes his statements that all things are full of gods and that magnets have souls. These claims seem to reintroduce divine and psychic elements into his supposedly naturalistic worldview. Diogenes Laertius reports that Thales considered God to be the mind of the world, the oldest being. If Thales believed in a cosmic divine intelligence, his position seems more theological than naturalistic. Perhaps he transformed mythology rather than rejected it, keeping gods while reconceiving their nature. The divine became immanent natural order rather than transcendent personal agency, but divinity remained. The resolution may lie in recognizing that our categories of natural versus supernatural are anachronistic. Ancient Greeks did not sharply separate nature from divinity the way modern Westerners typically do. The gods were natural forces, nature was divine. No clear boundary existed between the two domains. Thales could simultaneously naturalize explanation and retain divine vocabulary without contradiction. Water is both a natural substance and something divine. These descriptions do not compete, but complement. The apparent tension dissolves when we stop imposing modern dichotomies onto ancient thinking. Another consideration concerns the social context of Thales's intellectual work and its relationship to religion. He lived in a world where public religion structured social life, politics, and cultural identity. Openly rejecting the gods would have been socially dangerous and practically difficult to sustain. Intellectuals who challenged religion too directly faced persecution, as Anaxagoras and Socrates later discovered. Thales may have been more radical privately than his surviving statements suggest, or he may have genuinely seen no conflict between his natural philosophy and transformed religious sensibility. The scholarly debate also concerns what counts as explanation and whether naturalistic explanation is a coherent category. Modern naturalism typically means explanation through impersonal laws operating on mindless matter. But if matter is not mindless for Thales, if all things have soul, then his explanations are not naturalistic by this standard. Yet they are also not mythological in the sense of invoking personal gods with human-like psychology. Thales may occupy a third position that our dichotomies do not capture well. His cosmos is ensouled, but not populated by Olympian personalities making arbitrary choices. Some scholars emphasize continuity between Thales and earlier Near Eastern traditions rather than Greek innovation. Egyptian and Babylonian cosmogonies often featured primordial waters from which the world emerged. The idea that water is fundamental may derive from these older traditions rather than original observation. If so, Thales was transmitting and adapting mythological material, not breaking from it entirely. His innovation would lie in how he treated traditional material rather than in the material itself. He asked for reasons supporting the water thesis rather than accepting it on traditional authority alone. The question of naturalism connects to larger debates about the origins of Western rationality and science. Some narratives treat Greece as the unique birthplace of reason, contrasting it with mythological other cultures. This Greek miracle narrative has been criticized as Eurocentric and historically inaccurate. Other civilizations developed sophisticated knowledge systems that were rational in their own terms. Perhaps Thales represents one development among many, rather than a unique breakthrough in human thought. The debate continues, but Thales's significance does not depend on him being absolutely unprecedented. What seems defensible is that Thales initiated a particular tradition of inquiry with distinctive characteristics. This tradition emphasized public argument, criticism of predecessors, and naturalistic vocabulary, even if not pure naturalism. It produced cumulative progress through dialectical engagement across generations of thinkers. Whether this tradition was unique to Greece or had parallels elsewhere is a separate question from its importance. Thales stands at the origin of Western philosophy and science as we know them, whatever his debts to others. That historical role remains significant regardless of how we resolve the naturalism debate. Part 13. Eastern Tributaries. Thales did not think in a vacuum, but drew on intellectual traditions from Egypt and Mesopotamia. Ancient sources consistently report that he travelled to Egypt and learned geometry from Egyptian priests. They also indicate connections to Babylonian astronomical knowledge, whether direct or mediated through others. Understanding what Thales inherited helps us appreciate both his debts and his genuine innovations. He transformed what he received, but he could not have created his philosophy from nothing. The history of ideas rarely involves pure origination. It involves creative recombination and extension. Egyptian mathematics was highly developed for practical purposes like surveying, construction, and accounting. The pyramids and temples required sophisticated geometric knowledge to design and build. Egyptians knew how to calculate areas, volumes, and proportions needed for monumental architecture. They had discovered many geometric relationships that would later appear in Greek mathematics. But their knowledge was procedural, consisting of recipes for solving particular types of problems. They did not organize this knowledge into a deductive system, or prove that their methods had to work. Thales reportedly learned Egyptian geometric techniques and brought them to Greece. But his crucial contribution was asking why these techniques worked and proving that they had to work. The transformation from practical recipe to proven theorem represents a genuine intellectual revolution. Egyptians knew that certain procedures gave correct answers. Thales wanted to understand the underlying reasons. This shift from know-how to know-why distinguishes theoretical from practical knowledge. Thales initiated the theoretical approach that would culminate in Euclid's systematic deductive geometry. The story of Thales measuring the pyramids illustrates this transformation of Egyptian into Greek mathematics. Egyptians built the pyramids and certainly knew their heights through their construction records. But Thales showed that the height could be determined through geometric reasoning from shadows. The method was more important than the result because it demonstrated a general principle applicable anywhere. Any vertical object's height could be determined the same way, not just pyramids with known construction records. The move from particular Egyptian knowledge to universal Greek method exemplifies Thales's innovative contribution. Babylonian astronomy represented the most sophisticated celestial science in the ancient Near East. For centuries, Babylonian priests had recorded planetary positions, eclipses, and celestial events systematically. They discovered periodicities like the Saros cycle that allowed prediction of eclipse possibilities. Their records were detailed enough to reveal patterns invisible to casual observation over single lifetimes. This accumulated data represented an invaluable resource for anyone interested in understanding the heavens. Thales likely had access to Babylonian astronomical knowledge, directly or through intermediaries. Like Egyptian mathematics, Babylonian astronomy was sophisticated but not theoretical in the Greek sense. Babylonians recorded patterns and made predictions without explaining why the patterns existed. They did not construct geometric models of celestial mechanics or theorize about the structure of the cosmos. Prediction and observation sufficed for their purposes, which included astrology and calendar regulation. Thales and his successors asked what celestial regularities revealed about the nature of the universe. They sought understanding behind the patterns, not just the patterns themselves. The transformation from Babylonian astronomy to Greek cosmology involved asking different questions of the same data. Why do eclipses follow the Saros cycle? What mechanism produces this regularity? What is the structure of the cosmos that generates the observed motions of sun, moon, and stars? These explanatory questions were distinctively Greek additions to the Near Eastern astronomical inheritance. Thales initiated this explanatory project even if his specific answers were crude by later standards. The ambition to explain celestial phenomena naturally set Greek astronomy on its distinctive trajectory. Some scholars argue that Greek debts to the Near East have been systematically underestimated. The Greek miracle narrative sometimes portrays Greeks as unprecedented geniuses, creating ex nihilo. This narrative served ideological purposes, distinguishing Europe from Asia and West from East. More balanced accounts recognize that Greeks built on millennia of Near Eastern intellectual achievement. Thales's originality lies in what he did with inherited material, not in having no inheritance. Transformation and synthesis are genuine intellectual achievements even when building on others' work. The question of influence also runs in the other direction. How did Greek ideas affect other civilizations? After Alexander's conquests, Greek philosophy spread throughout the Near East and into India. Interactions between Greek, Persian, Indian, and eventually Islamic intellectual traditions produced new syntheses. The ideas Thales initiated travelled far beyond the Greek world that first developed them. Intellectual history involves constant exchange, appropriation, and creative transformation across cultures. Thales stands at one important node in this global network of ideas spanning millennia and continents. Part 14. Thales and Modern Physics. The relationship between Thales's water thesis and modern physics is complex, involving both genuine parallels and superficial similarities. Dismissing all connections as coincidental would be as mistaken as claiming Thales anticipated quantum mechanics. The parallels worth noting concern deep structural features of explanation rather than specific physical content. Thales sought unified theories, conservation principles, and reduction of complexity to simplicity. These methodological commitments characterize modern physics and trace back in Western tradition to Miletus. Understanding the genuine connections illuminates both ancient and modern scientific thinking. The most fundamental parallel concerns the drive toward unification that motivates theoretical physics. Physicists seek to explain diverse phenomena through minimal, fundamental principles and entities. Maxwell unified electricity and magnetism. Einstein unified space and time, then gravity and spacetime geometry. The Standard Model unifies electromagnetic weak and strong forces, though gravity remains separate. String theory attempts to unify all forces, including gravity, in a single theoretical framework. This unification program continues Thales's intuition that reality is fundamentally one, despite apparent multiplicity. Thales was wrong that water is the fundamental substance, but contemporary physics supports underlying unity. All ordinary matter consists of atoms built from protons, neutrons, and electrons. Protons and neutrons consist of quarks bound by gluons mediating the strong force. The diversity of chemical elements reduces to different arrangements of the same fundamental particles. A handful of particle types and 4 fundamental forces generate all observed physical complexity. This radical reduction of apparent diversity to underlying simplicity vindicates Thales's monistic intuition. The concept of conservation connects Thales to modern physics in substantive ways. If all things are transformations of water, then water is conserved through all changes. Nothing is truly created or destroyed. Water merely changes form while remaining water in essence. This anticipates conservation laws that structure modern physics at the deepest level. Energy conservation says energy changes form, but the total quantity remains constant in closed systems. Mass energy conservation, momentum conservation, and charge conservation all express similar principles. Thales's observation that water exists in 3 phases connects to modern understanding of phase transitions. Solid, liquid, and gas are different states of the same underlying substance with different properties. Modern physics explains these phases through statistical mechanics and the behavior of molecular assemblies. Temperature and pressure determine which phase is stable under given conditions. The same water molecules arrange differently in ice, liquid water, and steam, producing different macroscopic properties. Thales correctly intuited that one substance could manifest radically different observable properties. Phase transitions exemplify how qualitative differences can arise from quantitative changes in a single substrate. This was precisely the insight Anaximenes developed with his condensation and rarefaction mechanism. Modern physics confirms that matter can undergo dramatic qualitative changes through continuous quantitative variation. Superconductivity, superfluidity, and other exotic phases emerge from ordinary matter under extreme conditions. The Milesian program of explaining quality through quantity remains central to physical explanation today. Thales and Anaximenes were pursuing the right kind of explanation, even with inadequate specific theories. The question of whether there is a fundamental substance or field underlying all particles remains open in physics. Quantum field theory treats particles as excitations of underlying fields pervading all space. Perhaps a single master field underlies all the distinct fields of the Standard Model. String theory proposes that all particles are vibrations of one-dimensional strings in higher dimensional space. The search for a theory of everything continues Thales' search for the single arche from which all things derive. The specific candidates have changed. The explanatory ambition remains structurally identical. A cautionary note: we should not overstate the parallels or claim that Thales anticipated modern physics in any direct sense. He had no concept of atoms, fields, forces, energy, or the mathematical structures essential to physics. His water thesis was wrong in ways that modern physics can specify precisely. The continuity lies in methodological orientation and explanatory goals, not in physical content. Thales would not understand a physics lecture, but would recognize the ambition driving the research. That recognition of shared intellectual goals across millennia is significant without being exaggerated. The deepest parallel may concern the intelligibility of nature that both Thales and modern physics presuppose. Thales assumed that reality has a structure human reason can comprehend through observation and inference. Modern physics makes the same assumption expressed through mathematical laws that describe natural regularities. Why nature should be comprehensible at all is not obvious and might not have been true. That it is comprehensible, that mathematics describes physical reality with stunning accuracy, remains somewhat mysterious. Thales's confidence that the universe makes sense continues to be vindicated by scientific success. Part 15. Thales and the Life Sciences. Thales's choice of water as the fundamental substance resonates powerfully with modern understanding of life. Water turns out to be far more central to biology than Thales could have known or even imagined. This does not mean he was right about physics, but his biological intuition was remarkably prescient. Life as we know it depends on water in ways that vindicate his sense of its fundamental importance. The connections between water and life run deep through biochemistry, cell biology, and astrobiology. Examining these connections reveals that Thales glimpsed something profound, even if his framework was inadequate. All known life requires liquid water, a fact so basic it structures the search for extraterrestrial life. When astrobiologists look for life elsewhere, they look first for evidence of liquid water. Mars exploration prioritizes locations where water may have existed or may still exist underground. The moons Europa and Enceladus interest scientists because they appear to have subsurface liquid water oceans. The assumption that life requires water guides our entire approach to finding life beyond Earth. Thales's intuition that water is fundamental to life has been enormously vindicated by modern biology. Water's unique properties make it indispensable for biochemistry as we understand it. Its polarity allows it to dissolve ionic and polar compounds, making it an excellent solvent for biochemical reactions. Its high heat capacity moderates temperature fluctuations that would otherwise disrupt delicate biological processes. Its expansion upon freezing means ice floats, insulating liquid water below and allowing aquatic life to survive winters. Its surface tension enables capillary action, moving water through soil and up through plants against gravity. No other common substance combines all these properties essential for life as we know it. At the cellular level, water constitutes roughly 70% of most living cells by mass. Proteins fold into functional shapes, partly through interactions with surrounding water molecules. DNA's double helix structure depends on water molecules stabilizing hydrogen bonds between base pairs. Metabolic reactions occur in aqueous solution where reactants can encounter each other and enzymes can function. Remove water and cellular machinery grinds to a halt. Life as we know it becomes impossible. Thales sensed that moisture was essential to life. Biochemistry explains precisely why and how. The origin of life itself almost certainly occurred in water, probably in the early oceans of Earth. Current theories propose hydrothermal vents, tidal pools, or other aqueous environments as life's birthplace. The prebiotic chemistry that produced the first self-replicating molecules required a liquid medium. Water provided the environment where organic molecules could concentrate, react, and eventually become alive. If Thales meant that life comes from water, he was substantially correct about life's historical origins. The first cells emerged from water and remained dependent on water throughout evolutionary history. Evolution itself occurred primarily in water for most of life's history on Earth. For roughly 3 billion years, life existed exclusively in oceans, evolving increasing complexity while remaining aquatic. Land colonization began only about 500 million years ago, relatively recently in life's history. Even terrestrial organisms carry water with them internally, maintaining aqueous cellular environments. We are, in a sense, walking bags of seawater, carrying our marine ancestry within us. Thales's emphasis on water captures something deep about life's dependence on its aqueous origins. The water cycle connects living and non-living nature in ways that support Thales's holistic vision. Water evaporates from oceans, forms clouds, falls as precipitation, flows through rivers back to the sea. Plants absorb water through roots, transport it upward, and release it through leaves as transpiration. Animals drink water, use it metabolically, and excrete it, participating in the continuous global water cycle. All terrestrial life participates in this cycling of water through living and non-living compartments. The biosphere and hydrosphere are intimately interconnected through constant water exchange. Some researchers speculate about alternative biochemistries that might use ammonia or other solvents instead of water. These remain speculative because we have no examples of non-water-based life to study. Water's properties may be uniquely suited for complex chemistry leading to life, or alternatives may be possible. Until we find life based on different chemistry, water remains the only confirmed medium for biology. Thales's claim about water's fundamental importance to life remains unrefuted by any actual counterexample. His intuition, whatever its ultimate scope, has survived 26 centuries of biological discovery. Part 16. Limitations and Failures. Intellectual honesty requires examining where Thales was wrong, limited, or inadequate to the problems he addressed. Celebrating his achievements without acknowledging his failures produces hagiography rather than understanding. His framework had deep structural problems that his successors recognized and that remain instructive today. Understanding these limitations illuminates not just Thales, but the nature of theoretical inquiry itself. Good theories fail in informative ways that guide progress. Thales's failures were productive in this sense. We learn from his mistakes as well as his insights. The most obvious limitation is that water is simply not the fundamental substance of reality. Rocks are not made of water. Fire is not a form of water. Air is not modified water. Modern chemistry identifies over 100 elements irreducible to each other or to water. Water itself is a compound of hydrogen and oxygen, not an element in any meaningful sense. The specific content of Thales's theory was wrong in ways that became apparent to his immediate successors. Anaximander's objection that water cannot generate its opposite qualities was already devastating. More deeply, Thales provided no mechanism for how water transforms into other substances. He asserted that all things come from water, but did not explain the process of transformation. How does wet become dry, cold become hot, liquid become solid earth, or flickering fire? Without a mechanism, the theory describes rather than explains, labels rather than illuminates. Anaximenes addressed this gap with condensation and rarefaction, showing that Thales's theory needed supplementation. A complete natural philosophy requires not just identifying substances, but specifying how they interact and change. Thales's theory also lacked quantitative precision, expressing ideas only in qualitative terms. He said all things are water, but did not specify proportions, amounts, or measurable relationships. Modern science achieved its predictive power through mathematics, expressing laws as precise equations. Without mathematics, Thales's theory could not generate specific, testable predictions. It remained a conceptual framework rather than a scientific theory in the modern sense. The mathematization of nature that began with Pythagoras and culminated in modern physics was absent in Thales. The epistemological status of Thales's claims is also problematic upon reflection. How could he know that all things are water rather than merely believing or guessing it? What evidence could confirm or refute such a universal claim about the ultimate nature of reality? The theory seems immune to empirical test because any apparent counterexample could be dismissed as appearance masking underlying water. This unfalsifiability, which Karl Popper later identified as a criterion distinguishing science from pseudoscience, affects Thales's theory. He posed the right kind of question, but lacked methods to answer it rigorously. Thales's hylozoism, while creative, creates its own problems as an explanatory strategy. If all matter is ensouled, we explain motion by attributing soul to things rather than specifying mechanisms. Why does the magnet attract iron? Because it has a soul. This explains nothing about how the attraction works. Soul becomes a label for unexplained powers rather than an explanation of those powers. Later, mechanical philosophy rejected such vitalistic explanations precisely because they obscured rather than illuminated mechanisms. The explanatory gain from hylozoism is questionable, even if it avoids certain problems with inert matter. Thales also apparently accepted some claims that seem naive or inconsistent with his general approach. The Earth floating on water explains earthquakes, but raises the obvious question of what the water rests on. Aristotle noted this problem. If Earth requires support, why does water not require support? The explanation merely pushes the problem back one level without resolving it. A truly satisfying cosmology would need to explain cosmic structure without infinite regress of supports. Thales either did not recognize this problem or lacked resources to address it adequately. The limitations of individual thinkers should not obscure the cumulative progress of the tradition they initiate. Thales's failures were instructive precisely because his framework was clear enough to reveal where it failed. Anaximander, Anaximenes, and subsequent thinkers learned from his mistakes and produced improved theories. This self-correcting progression defines healthy intellectual traditions. No one expects the founder of a tradition to solve all its problems. Founders identify problems worth solving. Thales succeeded brilliantly at posing questions even where he failed at answering them correctly. Part 17. The Enduring Questions. 26 centuries after Thales, his fundamental questions remain open and continue to drive inquiry. What is the basic stuff from which all things are made? Why does the universe have the structure it has? How does mind relate to matter? What principles govern change and transformation? These questions have not been definitively answered despite enormous progress in understanding. We know vastly more than Thales did, yet his questions still exceed our ability to answer them completely. This persistence of fundamental questions indicates their genuine depth and difficulty. The question of fundamental ontology remains contested among physicists and philosophers. Is reality ultimately made of particles, fields, information, mathematical structures, or something else entirely? The Standard Model describes particles and fields, but leaves open what these entities really are. Physicists speak of quarks and leptons, but these may be excitations of deeper structures not yet understood. String theorists propose one-dimensional vibrating strings as truly fundamental, but string theory remains unconfirmed. The question Thales asked, "What is the Archie?" has candidates but no universally accepted answer. The unity of nature that Thales assumed remains both vindicated and challenged by modern science. Physics has achieved remarkable unification of forces and explanation of phenomena through fundamental laws. But gravity resists incorporation into quantum mechanics, and dark matter and dark energy remain mysterious. We do not have a complete unified theory of everything despite decades of effort. Whether such a theory is achievable or whether reality admits of multiple irreducible levels remains unknown. Thales's faith in underlying unity continues to motivate research but has not been fully vindicated. The relationship between mind and matter, which Thales addressed through hylozoism, remains the hard problem of consciousness. We understand much about how brains process information and generate behavior. But we do not understand why any physical process should be accompanied by subjective experience. Panpsychism has experienced revival as one response to the hard problem, echoing Thales' intuition about unsouled matter. Materialists, dualists, and panpsychists continue to debate without clear resolution, emerging. The question of mind in nature remains as puzzling as when Thales attributed soul to the magnet. The epistemological questions Thales raised about knowledge of nature also remain partly unresolved. What can human reason know about fundamental reality, and what are its limits? Modern physics describes nature with astonishing mathematical precision, yet interpretation of quantum mechanics remains contested. We have equations that work but disagree about what they tell us about underlying reality. The gap between predictive success and metaphysical understanding that affected Thales affects us too. We can predict what nature will do without fully understanding what nature is. The naturalism Thales initiated has become the dominant methodological assumption of modern science. Scientists seek natural explanations without invoking supernatural agents or divine interventions. This method has proven enormously productive, generating technology and understanding unprecedented in human history. But methodological naturalism does not settle whether ontological naturalism is true. Science proceeds as if nature is all there is. It cannot prove that nothing transcends nature. The relationship between scientific method and metaphysical worldview remains philosophically contested. What Thales achieved that remains undiminished was establishing a certain attitude toward inquiry. Reality can be investigated through observation and reasoning. Understanding is possible and worth pursuing. Traditional authorities can be questioned. New ideas should be evaluated by their reasons, not their sources. Complexity hides underlying simplicity that patient inquiry can reveal. These commitments define the scientific enterprise and trace back to Miletus in the 6th century BCE. The specific theories have changed completely. The animating spirit remains recognizably Thalian. We are all children of Thales, in the sense that our intellectual culture descends from his innovations. Every scientific paper, every philosophical argument, every attempt to understand nature rationally continues his project. He asked what everything is made of, and expected that human minds could discover the answer through inquiry. We have not fully answered his question, but we have learned enormously in the attempt. The questions that remain open are not failures, but invitations to continue the work he began. The Thalian project of understanding reality through reason will continue as long as humans remain curious. His final significance is not any specific doctrine, but the demonstration that such inquiry is possible. Before Thales, it was not obvious that nature could be explained without mythology or divine revelation. After Thales, naturalistic inquiry became a live option that proved extraordinarily productive over time. He showed that asking about the fundamental structure of reality was a sensible thing to do. His answer was wrong, but his question opened a domain of investigation still being explored. The first philosopher made philosophy itself possible by showing what philosophical inquiry could look like. This is the truth of life Thales revealed, that truth is discoverable through persistent rational inquiry. We stand in a tradition of questioning that began when one man in a Greek port city asked what everything is made of. The answer was not water, but the asking changed everything about human understanding. We continue to ask because he first showed that asking was possible and worthwhile. His legacy is not a doctrine, but a practice, not an answer, but a question that will never fully close. That practice of questioning, that refusal to stop asking, is the deepest gift Thales left to human civilization.